Okay, that gave me massive anxiety watching those guys pack up. This was stressful enough just doing a presentation. I cannot imagine what it must be like to try and have a physical demonstration, so hats off to the last guys. So, okay, my name is Seán Carroll. Thanks for coming to this talk. This talk is going to mainly be about how I've used Blender throughout my sort of career within engineering, and more recently how that's led into add-on development, or what I call here low-code add-on development. So I'm a structural engineer by training, and so the context that I'll be talking about is an engineering context, but really the message, you don't have to know anything about engineering. The main takeaway message for this presentation is, I'm going to play that, don't get rid of it. The message for the whole presentation is really just take your domain expertise and bring that towards add-on development. It's really never been easier than it is right now. So a very brief background to me. As I said, I'm a structural engineer. I was a university lecturer in engineering for about 10 years. And then from 2022 until now, I've run engineeringskills.com, which is an online learning platform for civil, structural and mechanical engineers. And what we focus on is helping engineers understand analysis techniques, how the mechanics works behind the software that they use day to day, and then how to use Python within their day-to-day workflows. Throughout all of that, Blender has been a relatively constant presence for me. From a hobby back in 2009-ish, I think I saw a 3D model of a car at one point online, and that led me to Blender. And ever since then, Blender has become a bigger and bigger part of what I do, and much more so as I've moved away from the sort of coalface of working as an engineer and more towards education. And Blender is a really core tool. So I'll just start off here by just showing a very brief case study. And I start here because this is was the starting motivation for wanting to pursue add-on development. So this is it's a relatively famous structure if you're a structural engineer who's interested in fabric structures. As I say, it's a fabric structure by the great engineer, architect Fry Otto, the late Fry Otto. And from an engineering perspective, what makes that structure really, really interesting is it exhibits what we call geometric nonlinearity. So one of the things as an engineer you're most interested in, is the distribution of forces within a structure. Because if I know how the forces are distributed, I get the stresses associated with those forces, and I can design materials to withstand those stresses. But the problem with a structure like this is it's flexible, right? And because it's flexible, the distribution of forces changes as the shape changes. And so it's kind of for most engineers, it's kind of a headache to try and analyze a structure like that. So you end up having to do an iterative analysis process. And you essentially let the structure, you do a simulation where you let the structure settle and relax into its final state, and you extract the state of force, or the force distribution from out of the structure at that state. But the starting point to that iterative process is a process called form finding, where we have to try and identify what is a reasonable starting point for our simulation, and then we proceed from there in an iterative manner. Now, there's algorithms that we can use to do this relaxation process, but it turns out it's called form finding. This process. It turns out that Blender's cloth simulation happens to be a really great tool for this as well, a really nice, easy tool to use. So this is a model of that structure, and the cloth simulation that was used to get the initial shape of the structure. You'll see it pop now in a second when the actual cloth simulation runs. And of course, because we're working in Blender, for most of you guys who are artists, like this is sort of bread and butter stuff for you. Like, you use Blender as an artistic tool. I am an engineer, and for me to have access to nice rendering, nice animation to communicate concepts is fantastic, right? It really makes a big difference to me. So form finding is this process. It gives you your initial position. Then you take that geometry data over into, for me, that would be something like a Jupyter notebook. You do your iterative analysis, and that gives you your force distribution. Those colors are indicating the axial force. The structure was shown as the actual structure is a fabric structure. This is modeled as a cable net version of that, a cable net structure. One of the most famous examples would be the Munich Olympic Stadium as a classic example of a cable net structure. Again, that's also Fry Otto. So once you do the analysis, once I do the analysis, I then take it back into Blender to do some more, nicer visualizations, because a big part of what I'm trying to do with my work is communicate to other people who I'm teaching this stuff to. And Blender, as I keep saying, is a fantastic tool for me to just take, a matplotlib visualization and really make it pop inside of Blender. So that process, at that point, was do the modeling in Blender, then take all of the geometry data out of Blender and bring it into, for me, a Jupyter notebook, do the sort of engineering heavy lifting, the analysis in the Jupyter notebook, and then do some basic visualizations, but really take all of the results data back into Blender and do a fancy visualization in Blender. But of course, we can run Python code in Blender anyway. So the sort of logical question to ask is, well, why don't I just do it all in Blender, the modeling, the analysis, and the visualization? And once you're there, it's a relatively short hop to think, well, why don't I just build a structural analysis add-on, something that takes these sort of workflows that are sort of piecing bits together and funneling data here and there, and just build a nice add-on that presents a nice workflow to the user, and they can do their analysis and visualization in Blender. So that was the kind of idea that was sort of circling around in my mind around about the time I came across this add-on called Serpens. I'm not affiliated with Serpens, I'm just a really happy customer of this particular add-on. It allows us to do node-based add-on development in Blender really, really easily. So we could already build add-ons in Blender using just code, and straight after this presentation, there's going to be an excellent presentation down below, which is going to be, a great demonstration of that. But then this guy called Josh Nauber released this add-on Serpens in 2020, and I think it was quite an innovative idea. It's an add-on for creating add-ons. You might have come across it, you probably have come across it. And it just facilitates node-based visual scripting. And for me, it did two things. One, it raised the level of curiosity, because I saw this add-on and allowed you to create add-ons, and that was just an interesting idea, so I wanted to sort of dig in and see what's that all about. So the curiosity level increased. But the other thing it did was it dropped the barrier to getting started. Like, I'm quite comfortable writing code. I've been writing code for years. If I dedicated enough time to it, I could have built it with just pure code. But like, I'm busy, we're all busy doing other things, and to dedicate the time to do that was just, for me, just a little bit of a bridge too far. It never got started. But that's what this particular add-on did. It just dropped that barrier to getting started. And then, I got started doing it, basically. And so this is the basic idea, right? If I want to build an add-on, and let's say I want my add-on to live in the end panel where most of the add-ons live, well, then I just start with a panel node. I give it a label. If I want to put a button in my panel, I just add a button node. And so with two nodes, I've kind of started my add-on, right? I have an add-on, right? It doesn't do very much, it doesn't do anything, but it's still an add-on, and I've made my impact on the Blender user interface. And if you haven't built add-ons before, and it's not something you're very familiar with doing, that's a really powerful first step. It's just two nodes, no code, and I now have something that lives in the user interface of Blender. And for me, at least, that was all I needed to pull the next thread and to just keep going and going and going. So now I might want my button to do something. So I can take my button and I can point it towards an operator node. An operator node you can just think of as the starting point for the execution of some logic inside of Blender. So in this case, I want my operator to point to a script. So I have a run script node which just points to a script. So now I've got that link between a button in my user interface and then some code that I can run that my button essentially executes. And so just taking these very simple ideas, simple nodes basically, and combining it with code. So it's not no code. It's a hybrid between nodes and coding. If I was to try and recreate all of the engineering analysis logic within nodes, I think that would just be a bridge too far. It would be too far for me anyway. So there is certainly parts within this whole process where it still makes sense to run scripts and have your logic executed in scripts. But anyway, using that approach, I was able to go and build the add-on that I wanted to build, which was this structural analysis add-on. So the way it works is we can build a structure in Blender. This is trivially easy to build in Blender, this structure. But if you're familiar with structural engineering software, it's not. So we can give all of the members within that structure the engineering information, so the materials, the cross sections. We can specify the supports, essentially the foundations, how the structure is supported. We can apply the self-weight of the structure, so it resists its own weight. We can add additional forces to the structure. And then we can run our engineering code and then solve the structure and then use Blender for what it's good at, which is helping us visualize the behavior of the structure. And here we're using Blender's material system to visualize the distribution of forces, what I talked about at the very start, that distribution of forces within the structure under the action of those external loads. And so, I mean, this is just engineering, right? Unless you happen to be a structural engineer, that might not be very interesting. But for me, that's brilliant, right? So that's just the ability to take your domain expertise, whatever it happens to be, whatever your jam is, and combine it with this sort of workflow for building add-ons, I think is a really powerful, it's a powerful way to work in Blender. So just a quick note on what makes Blender so good for this and why I think it's fantastic for me in my applications is that modeling in Blender is fast, it's easy, because obviously it's built for people who model stuff, right? If you've used, as I said, if you've used engineering software, it tends to be incredibly painful to use in terms of modeling. It always tends to be table-based, so you're putting in individual nodes in what looks like a spreadsheet, and then you're connecting them all together. You know, that's a difficult way to model, to say the least. There are exceptions out there. Grasshopper, if you're familiar with it, is a parametric modeling software which will be industry-leading certainly within construction. But it's a very specific kind of modeling. Most run-of-the-mill software is quite tricky to use. With Blender, obviously, we get our Python API, and then for me, the things that really add massive value are the animation and rendering system. Again, my job now really is more about communicating ideas and concepts and theories to students, and less about coming in and designing buildings. So that really helps me. So a little look behind the scenes of the actual add-on itself, just to give you a flavor of what does it look like to build an add-on with this approach. So you've got this is the snapshot of the development file for that particular add-on. So if I want to go in and I want to work on it, I just open up Blender and then basically start pulling nodes together. So we have the add-on shown here. This is the visual scripting window that we get with the Serpens add-on. And because Serpens is an add-on itself, we have its own end panel over here, which has a range of different things. So up at the top there, you've got the list of all of the node trees that goes into making that add-on, the StructureWorks add-on. We've got below that assets that get bundled with the add-on if the add-on is shipped, and then a whole lot of other additional useful information relating to the add-on. And so one other thing, before I move off this, I wanted to touch on is this idea of composing node functions. When I started out looking at Serpens, of course I was curious about how it worked, but as a person who's been writing code for 15 or 20 years now at this stage, I was really skeptical that I could build something that was scalable and maintainable or manageable using nodes. I mean, I've used geometry nodes, and every time I use geometry nodes, it ends up looking a mess, and that's not geometry nodes' fault, that's my fault. But nevertheless, it was this ability to build node functions that actually was that mental, it got rid of that mental barrier I had. And so, for example, this is one of the node trees that it's actually the analysis node tree. It's responsible for doing the structural analysis. And the entry point into this node tree is this node here. It's a panel node, and everything flows to the right from there. But what you notice is on the left-hand side, there's a load of colored blocks. And what they are function declarations. So I'm declaring specific functions, and then I'm calling them at various different locations within the node tree. And this is a small thing, but it happens to be a really big thing when it comes to trying to write code that somewhat approximates how you would write code traditionally, in whatever language you tend to write code in. So you have plenty of examples of this. And in fact, there's one node tree in here called, you won't see it, it's up there, it's called common functions. And it just happens to be a node tree full of individual function definitions that happen to get called in a whole lot of other node trees. So it's a really nice way to try and make your code manageable as it gets bigger and bigger. So that was all just using regular vanilla Python. And so the next question is, can we make use of, within an add-on, could we make use of all of the other libraries, the world of Python libraries that exists out there? And for me, Those would be things like OpenSees. Again, that might not mean anything to you, but for engineers, that's a really big library because it allows us to do static and dynamic finite element analysis. Like, engineering skills teaches engineers how to write that code and how it all works, but practically speaking, it's already been written before in a whole load of other libraries, and so if we can plug into those libraries from our add-on, that then massively expands what you can do with your add-ons. Finite is another one for finite element analysis, and Gmesh is a fantastic library. It allows us to build the finite element meshes. A massive pre-processing step for any finite element analysis is mesh generation. It in itself is a huge task to undertake, but there's already libraries that are really extensive, battle-tested, that have been built and used for years, that have got all this code already. And so the big thing is, how can I access those from my add-on? So the thing is, if I can access them, if I can plug into all of these existing libraries, well then, all of a sudden, Blender starts to become, in my eyes, it's a development environment. That's how I look at Blender now. It's a 3D development environment as opposed to a 3D piece of software that I kind of bend to do what I want to do. Now, although, I mean, that's obviously VS Code on the right. That's where I'm writing the code. I don't love writing code natively in Blender. This is just much more familiar to me, but that's kind of beside the point. These two windows are really tightly coupled. And so it's just a point to say that once you can access all these external libraries, well then you really can view this as one sort of development environment. And as an engineer, a lot of my work is very, I suppose, technical, code-based, mathematical, but it also has a very visual element to it. I'm also always trying to visualize things in the 3D world, structures and data associated with those structures. So it's a really fantastic, it's been a kind of a real shift in how I think about Blender. It used to be the tool I would go to all of the time, but now it has become a real central tool to basically everything that I do now. Okay, so I suppose the question is, if we can access these libraries, and that then is the question then is, how do I access the libraries? We can. There is ways to do it. Blender doesn't ship with most of these libraries already. I can't just pip install. If you've ever tried, you'll hit a roadblock. There are various workarounds online in terms of how to do this. I've always run into roadblocks with them basically until I happened upon the way that I'm going to show you now. I didn't invent it. I'm not a professional anything in Blender, so there might even be better ways to do it than what I'm going to show you, but it works really, really well for everything that I've built. Then the other thing is, I don't want to distribute code. I don't want to distribute the code from these libraries with my add-on because it's not my code to distribute, and there's issues obviously with that. But if I do ship an add-on and it can talk to all of the libraries you already have downloaded on your machine and you already use, well, that's fine. So how do we do it? This is how I do it. We have Blender running. You've got your add-on running inside of Blender, inside of Blender's Python, essentially. And then every time the add-on wants to use a library that we don't have in Blender, what we do is we spin up an external process on your machine. You spin up a process on your machine that basically will just have access to all of the libraries you already have on your machine. And so when I hit the button that says Analyze Structure, all I want my add-on to do is collect up all the information, the geometry of the structure, the loads, the material information, etc., package it up into JSON, and then just ship it across over to the external process, run the external process, run that OpenSees code, package up all my results, and send them back for visualization inside of Blender. Now, it looks like kind of a clunky workflow, but it works really surprisingly well. So within your add-on that you're building, you can set up within your add-on's preferences, you can ask the user to essentially point to their Python interpreter, that from where they will access all of their external libraries. And in this case, there's a little script written that just checks for OpenSees that it's on your machine, and this is the version of it that you have access to within your add-on. Then you can kick off a subprocess from within the add-on. All of the scripts that process is going to use, like all of the scripts that make calls to OpenSees or Gmesh, they can still get shipped with your add-on. So it's, from the user's perspective, it's quite seamless. And then we just do some sort of standard inter-process communication to ferry information back and forth between the two processes. And that gives you access to anything you have already on your computer from within your add-on. Yeah?
I to do the pip install call in a script in Python? Why would you?
Anytime I've tried to do that, it hasn't worked.
Oh, I did it. It can work. Yeah, but it's from Python, from Blender 4.
You have to align your. You got lucky. It's hard.
No, I did multiple times.
But no, I know. But the problem is like in my case, I have like 7 different Python installs on my machine.
Yeah, that's why I did it locally, so that I don't have to be confused with all the other.
I'm talking locally. I have set for different applications. So if you have something that needs 3.11 and one needs 3.9 and one needs 3.13, if you can't just pull that stuff into Python to Blender unless it exactly aligns with the version that Blender is using.
Yeah, but I did a pip update and it worked.
You're a lucky man.
So, like I say, there are ways to do it, and there are various. I mean, I've gone down a lot of rabbit holes trying to make it work myself, and I caveat that by saying I'm not a professional in Blender, right? So there could be good ways to do it. I don't know. This is what works for me. And the most important thing is it's seamless from the user's perspective. So the user doesn't have any appreciation that anything is being spun up externally and there's information being shipped across. They just hit the button and the results appear within the add-on. So basically, you want to test this. You want to basically build a workflow, build another add-on that solves an engineering problem that's going to use these different libraries. And so we need an engineering problem. So I'll just sort of step slightly to one side and just imagine you were an engineer. One problem you might face is that you're trying to analyze a floor like this. And one of the things you've got to do is confirm that the floor is not going to bounce too much as people walk across it. So you have to do a dynamic analysis of the floor and extract what are called the modal characteristics, the dynamic characteristics of the floor. And those are frequencies. So every structure, everything has a series of frequencies that it wants to vibrate at, essentially. And associated with each one of those frequencies is what's called a mode shape, which more or less tells us where on that structure wants to vibrate at those different frequencies. And so if I'm an engineer and I'm looking at this floor here, for example, what I can do is a modal analysis and extract all those frequencies and all those mode shapes. And what that will do is, for example, if I spot on this floor that there happens to be a vertical mode shape at around 2 hertz, I know I could have a problem because people tend to walk at about 2 hertz. And so they're imposing a dynamic load on the floor at 2 hertz. If you remember your secondary school physics, if the floor has a frequency of 2 hertz, you can get resonance, and the floor vibration builds up and becomes perceptible, and you can get all sorts of problems and complaints. So the thing to do now is build an add-on where I can define the slab edges. This is kind of a proof of concept more than anything else. Specify supports, materials, the depth of the slab, concrete slab, the mesh size, use Gmesh to mesh it, and then perform a modal analysis in OpenSees. Again, you can write all the code to do everything that this is going to do and this is going to do, but it ends up being a lot of code, and you really need to know your onions if you're going to do it. But if you use Gmesh and OpenSees, it's all written for you already. Of course, it's also advisable to know what's happening under the hood as well. But then use Blender to visualize all of this information. So you've got the thing to point out here is you've got a temporal component to these dynamic characteristics in terms of frequency, but you also have a spatial component as well. So Blender is an ideal tool to be able to visualize this. So it turned out to be really, really easy to build this add-on. And so this would be an example of, like, if you're an engineer, in my case, you face a problem that you happen upon every other day or frequently. A little bit of time spent building a custom tool was going to save you a lot of time down the line. So what you're seeing here is the list of modal frequencies here. That's modal mass. It's another parameter we don't really care about right now. But associated with each one of those frequencies is a shape, a mode shape. And you can see a mode shape there for the first frequency. So if I just show you the workflow, we can see we're looking at the first frequency. You're only seeing the side view of the slab. We go down to the second modal frequency, and then the third modal frequency. You can see the shape changes, and we can visualize the frequencies, at the correct frequency. So the workflow is to just specify the slab edges, specify any internal supports. This is the key part. Use Gmesh to develop the finite element mesh. So you just hit the button and the mesh appears, basically, even though it happened in an external process. Define any supports for the structure. And then, again, another button click spins up an external process that runs OpenSees to perform the modal analysis, and then the results just get shipped back into Blender and we can visualize them. So we can deform the mesh to visualize the mode shapes, and then we can animate those mode shapes as well, as you saw. So we can get a really good intuition as engineers looking at a particular floor in a building. Where is that floor going to vibrate, at what frequencies? And so, for example, if I have a walkway where the people are walking up and down, and there's a partition wall, and someone's on the far side of that wall, sitting at their desk with a monitor on one of those monitor arms, we'll be able to spot and see if their monitor is going to start shaking as people walk up and down the hall. So that's kind of, it's an engineering problem, but it's just an example of solving a very specific problem that you may have. So the takeaway message here really is that Blender development or add-on development is really very doable. If you can use Blender, you can absolutely build add-ons. And if you use Blender a lot, you could probably benefit from some custom tooling. So thanks to everyone that makes Blender, and nod to Josh Nauber for bringing out Serpens, because it's what gave me the push to pursue it a bit more meaningfully. And then finally, if you want to get started, I have a course that you can access completely for free that walks you through the process of building that add-on. So just use that code BCon25 and you can enroll in that course. You have access to it forever. And it's me walking you through how I built the add-on. You might find it helpful. So that's it from me.